question 4, part 1, asks us to find an expression for the amount of material left at a given time. We're given certain information with this question. So we're told initially that the material is known to decay at a rate proportional to the amount present. So let m equal to the amount, or I know there are some chemists out there, but in maths we abuse this a little bit. We call amount the same thing as mass. So the amount or the mass present, and we know T is of course the time. So we know that the decay, the rate of change in the mass per unit time is proportional to the amount of a material remaining, or the mass of the material that is left. We are also told that after 4 hours it is observed initially, so m0, sorry, is equal to 256 milligrams, and we're told that m at 4 hours later is going to be only, it's lost 6.25%. So this is 1 minus 0.0625, so 6.25% times 256. And it turns out this number is 15 over 16 times 256. So we'll just leave it as that for the moment. So now we have to use this information to find an expression for the mass of the material remaining at time t. Well, first thing we do is we take this equation here and we turn it into something, we turn it into an equation, because it's at the moment just a proportionality. So we know that if this is true, then dm by dt is equal to some constant k, some constant of proportionality, times our mass m. And we can solve this differential equation. This is a simple separable differential equation. So the integral of 1 over m dm is equal to the integral of k dt. So in other words, ln m is equal to kt plus c, integrating both sides. I'm not putting a modulus around my variable m, because m here represents the mass, and mass is a scalar quantity. It can't be negative. So I can say this equates to raising everything, taking both sides and raising that e to the power of that. I get m is equal to e to the kt plus c. Now this is, of course, we know, equal to e to the c times e to the kt from our log rules, and so I can just rewrite this as ae to the kt is equal to m, where a is equal to e to the power of c. So I know initially there are 256 milligrams, so this is the same thing as m when time is equal to 0. So when time is 0, m is equal to 256 is equal to ae to the k times 0. So e, this whole thing here, e to the k times 0 is going to be 1. So we know that a is equal to 256. Now we have to find this constant here, k. So to do that, we substitute in m is equal to 15 over 6 times 256, t equals to 4. This stage it's quite clear why I wanted to leave it as 15 over 16 times 256, because I'm going to have 256 times e to the 4k. That means this and this will cancel out, right? And so I get 15 over 6 is equal to e to the 4k, so 4k is equal to the natural logarithm of 15 over 16, and k is equal to a quarter the natural logarithm of 15 over 16, which can also of course be written using our log rules as 15 ln 15 over 16 to the power a quarter. So what does that make my expression for mass? well, the question is where I'm going to write it. So, okay, let's just remember that. Okay. Sorry, there we go. So, I had A is equal to 256. I had K is equal to ln 15 over 16 to the power a quarter. And I had M is equal to AE to the KT. So let's substitute that in. It's going to get a bit messy, but this will be 256E to the T ln 15 over 16 to the power of 1 over 4. Now again, I'm going to use my log rules here because this t down here, it's the same thing as having 15 over 16 to the power of a quarter to the power of t. So this is 256 e to the ln 15 over 16 to the t to the power of 1 quarter. Let me just rewrite that. Power of a quarter to the power of t. But of course, using my exponential rules now, I don't have to write it like that. I can multiply the t inside and I get t over 4 here. And then I've got e and ln right next to each other, so you know what that means. That means I can go 256 and these two are going to cancel out. I get times 15 over 16 to the power of t over 4. And this is my expression for the mass of material remaining at t hours after it is first observed. So for parts 2 and 3, it's simply a matter of substituting in the corresponding value for mass or time, rearranging and solving. So that shouldn't cause any problems, so I will stop here.